LGTM. Who's heard of this word before? Hands up. Quite a few of you. Now, LGTM may mean that your code has been reviewed by your fellow developer and you're ready to push to production. But it could also mean, let's get this merged, or let's gamble, try merging. Put that on a t-shirt. Hello, my name is Mai Nishitani. I'm a senior solutions architect from AWS. Now let's say it's a Friday afternoon and you're a developer and your code just got LGTM'd by your fellow developer, so you're ready to push to production. You have this awesome e-commerce web application called Unicorn App, and it's running on EKS. So you push to production, and guess what happens next? So you get a flurry of messages from my manager, from the IT ops team, and everybody is saying, what did you just break? And it turns out that I misconfigured something and our e-commerce web application was down for an entire day with a 500 error. So according to IT ops, who had to go in there and fix it, they said that there weren't enough replica pods running, so the load balancer couldn't pass a health check. Therefore, we had a 500 error. So not a great result. So is it because we rely too much on traditional CI/CD processes when deploying an application? And this is what it looks like from a developer standpoint. I write code, I push it to Git, and then it gets packaged up into a container image, into Amazon ECR. But what if the application requires Amazon DynamoDB? This is where I log a ticket, and it goes to the internal ticketing system, and then the IT ops or the platform team picks it up, and they might use AWS CDK or Terraform, some kind of infrastructure as code, but it may take days or if not weeks if we're lucky. And then finally, DynamoDB gets provisioned alongside the application code that gets pushed to EKS. Now, is this a really fast process end to end? Not really. And are devs and ops working together in this case? I don't think so. So, what could be the potential solution? According to Evan Botcher, he says platform engineering is a collection of self-service APIs, tools, services, and knowledge working together to form an internal platform. Now, the key word here is self-service, and that's why many customers are building their own internal platform for that self-service capability and all of these benefits, including velocity. So how do we get from idea to production quicker with a platform? All the while operating safely within guardrails for these internal teams, improving governance, and improving efficiency so you don't have to log a ticket every single time you need a service or infrastructure. But before we get to that utopia platform state, there's 3 different challenges. Now, the first challenge is, in order to build this platform, you need to standardize, and that may take time. Second of all, the number of tools that are available out there. And at any given organization, you might have UIs or APIs that you're managing per workflow. Not to mention, lots of tooling that your preference is within a single team. So how do we consolidate all these tools? And lastly, there is no single source of truth. As a developer, you might see Git as a source of truth. For the IT ops and the platform team, you might have a different source of truth. So that means that, again, devs and ops are not working closely together, creating silos, creating less governance. So can we perhaps use Kubernetes as the foundation of this internal platform? So let's dive a little bit deeper to see what that looks like. So once again, we're here. I'm a developer. I push code into Git. That doesn't change. That's my source of truth. But what if we can leverage infrastructure code in YAML and push that into Git and have the IT ops or the platform teams involved in seeing Git as a source of truth as well? Now from there, the Kubernetes controller takes that and deploys AWS services within minutes. Now that's a vast improvement over weeks. And I've seen customers build their own custom controllers, which is possible, but it can be a difficult process and maybe not a great use of developer time. So how can we leverage something that already exists? Perhaps GitOps. Now GitOps provides that drift detection capability to provide you that inbuilt governance. Now let's take a real life example here. You can see here, observe, analyze, and act, but who's turned on an air conditioner before, ever? Yeah, quite a few people. Now me being from Queensland, I walk into a room, the current state is 30 degrees Celsius. So what do? I turn on the air conditioner, I set it to the desired state of 24 degrees Celsius. And so the air conditioner acts and cools it down to keep it continuously at the desired state. Now the GitOps controller is exactly the same. It looks at the current live state in Kubernetes, it looks at the desired state in Git, and then continuously deploys infrastructure or configurations to keep it at that desired state. So what if we can leverage Argo CD as the GitOps tool of choice? Now, Argo CD has capabilities around self-healing and auto-sync that could have saved me from my own misconfiguration from that fateful Friday evening. So let's take that into action with an actual demo. So again, I'm a developer, I'm writing some code for the new UI feature, and I'm using Git as a source of truth, and Argo CD as the GitOps tool of choice. So wish me luck that there are no more 500 errors. So here we are in the Argo CD UI, and we're going to be defining our web application here. And you'll see in the current state, we should have 10 replica pods running at all times. So that's our desired state in production. And that's great, it's in a healthy state. Let's go to the settings. We're going to be enabling the auto-sync and self-healing capabilities, so I don't get caught out in my own misconfigurations. And while we're here, let's take a look at the ECR repository, make sure that that's linked to this web application in just a second. We're also going to see the Kubernetes Live manifest details as well. All right, so I've enabled those features. Let's take a look at the repository. Okay, that's there, great. And the Kubernetes Live manifest should be there. And if we need to look at any health-related details for our deployment, we can check it out in the last tab. Now we're back in the terminal. So I'm going to add the files that I've been working on into Git, and then I'm going to commit with a comment, and then I'm going to push into Git as well. Now the great thing about Argo CD is that not only can you see the visual elements within the UI, as you just saw, you can also check your deployments via CLI, so you have that option as well. So I'll be deploying some new objects into Kubernetes, including the service, the namespace, and the deployment in itself as well. So that should be in progress. So when the final push happens, you should be able to see these objects. Okay, almost there. Okay, so great. The deployment is currently in progress, and the config map, etc., has been deployed. So let's take a look at our deployment. We've got 10 replica pods here, as expected, and it disappears. Okay, that was not supposed to do that. I'm in a bit of trouble here because I promised there'll be no more 500 errors. So this is awkward. But luckily, Argo CD's self-healing capability kicks in, and we're back up to 10 replica pod, the desired state. So luckily, I've enabled those features before I get caught up in my own misconfigurations. So the deployment is progressing at this moment, and let's make sure that the app is in a healthy state before I sign off for the night. I have one more check, and that's to make sure that our actual web application is running. Okay, we're nearly there. We just want to make sure that the app is healthy, and then we'll move on to our e-commerce application. And I want to make sure that I can add a watch to the cart, and that's our final check before I can say, yep, we're done. Okay. We're at our e-commerce application. Let's select a watch, the Chronograph Classic watch, and let's see if we can add it to the cart. Fingers crossed. Oh no, another 500 error. Well, this is not meant to happen, but I know the root cause is not to do with the replica pods. You saw that Argo CD self-healing capability kick in, and we're back to the desired state. So it's definitely not to do with that. So what could it be? Remember, we logged a ticket to the IT Ops team. And guess who's looking into that ticket? Frank from the IT Ops team. So maybe he can help me fix this 500 error. Frank, can you help me out here?
I'm here. Thanks, Mike. As a solution architect from AWS, I talk with many developers and operators. Developers basically want to have autonomy. You want to deploy your application runtime and also dependency in one go. In this particular case, developer want to deploy database servers, need to learn lots of things, but made a mistake. That's the reason, hey, operators, help me out. As operators, do you want to get involved in day-to-day troubleshooting? You have lots of other things to learn. You need to attend an event like this, right? And you want to have standard across the board to prevent human error. You can see the battle. Is there a solution can make both of them happy? The answer is yes. With the magic of infrastructure controllers. This is the component you can extend Kubernetes API to external APIs. Enable developer to deploy your runtime and dependencies in one go. But same time, still follow standard defined by operators. How cool is that? Two popular offering in the market, ACK, AWS controllers for Kubernetes, basically run and managed by AWS. It support a wide range of the AWS services. Another offering is CNCF open source project Crossplane. Basically have wide community support and support a wide range of providers. We talk about this challenge, right? So very often, as developer, you need to rely on another team, maybe platform team, either raise a ticket or you learn all the nitty-gritty stuff over the back end, which ended up in long time, not minutes, but hours, even weeks, to get a whole application stack up to running. With the help of the infrastructure controller, as you can see, we get rid of these dependencies on another team. You simply just consume the standard specified by operators, can deploy everything in one go within minutes. The concept here basically is quite simple, right? So you have a operating team to create that providers for you. Crossplane basically supports the provider to extend your capability to provision external resources. The managed resources basically represent the resources managed by Crossplane. So this is a simple example to create an S3 bucket. And also, probably in some situations, you need more than an S3 bucket. For example, database and IAM policies. So here, we create a template called composition. You group them together as logical components, and in one go, you can deploy all of them. And then you define a specification here we called resource definition, XRD. So basically, when you apply this, CRD, which is a customized resource definition in Kubernetes, will be deployed on your cluster. And then it will trigger provisioning of the backend resources. How about the developers? Do I need to learn all this stuff? Not really. What you really need to learn is what you really want. In this case, I just specify very simple parameters here. That's it. And I will trigger the provisioning in the backend, including the whole application stack, networking components, IAM roles, databases, so on and so forth. Right? Basically, you just consume all this stuff already specified for you. Let's get into the demo. I will walk you through a simple scenario. You just specify a simple database table. That's what I need as a developer. And then I need some permissions like service account mapping with IAM role, IAM policies. And then things should work. That's step one. Step two, what if someone make a change? I want to make sure always infrastructure controller can reconcile the current state with the desired state. The third step, what if you have someone to attack you or basically do some things you don't expect it? Now we have some guardrails in place. Basically, you can narrow down your scope in different accounts or even isolate it in different namespaces. And even better, how about leverage third-party like policy enforcement engine like OPA Gatekeeper to put more guardrails in? Let's talk about demo. So basically this demo, first of all, is the UI for Argo CD. We are going to just create application to start with. So this application is quite simple. We just specify some simple parameters. Give a name, and then most of stuff just by default. And we need to specify the Git repo. That's our source of truth. And put the folder, that's where my code resides. And destination, that's my default Kubernetes cluster. So all this basic stuff. So what I defined here basically is the whole application stack on the umbrella of this application. Let's start to think. When you click the button, automatically Argo CD will pull the latest code and deploy to my environment. So it's straight-tier applications, including UI, backend, and also very important. Remember last time we messed up with database, right? Here, let's see how it goes. It's in progress. Yeah, as a developer, I don't need to worry about lots of the configuration, right? As you can see, I simply claim a database table in my code, and it will provision the backend database, all the IAM roles, and also the policies on your behalf. How cool is that? And it's very consistent, right? We don't need to change all the time. It build once and consume. So here it's going on, and you can see some policies already provisioned, IAM policy. It will take a while. So while we're waiting this database to be ready, let's look at the prerequisites we installed to enable this functionality. This is my EKS cluster. You have lots of resources already pre-configured. First of all, I installed Crossplane. And then I installed lots of providers. As mentioned, this provider is a mapping. It's basically the customized API mapping to external APIs. So this one, DynamoDB, this is a custom API mapped to the AWS API to trigger provisioning of your database, which is DynamoDB. Yeah, the provider installed, and then we can go back and have a look at the progress. It's getting there. Lots of components already provisioned. Let's go to our front end. Front end, this is a straight-tier application. I have a networking load balancer in front. Let's find the URL. And just do a copy paste. It's working, right? But wait a second. Last time we got error. And this time, we hopefully working as expected the whole process, right? let's do a check. The database seems like working, already provisioned, but go to our, sync OK. Let's go back to our AWS console. Yeah, this table is there. But let's do a run to see what's there. Nothing. Yeah, this table is there, but no items yet. How about we go to our UI and just click button to add one product into the cart? Yeah, that's one. Remember the price here, 793 or something. And then we do a refresh. Hey, it's there. So which means we prove it works, right? From end to end. As a developer, you don't worry about backend. It's already configured for you. You consume that for, in one go. So whole application works fine. But having said that, have we solved all the problem we just mentioned? Actually, I want to show you is, in this case, as a developer, that's all you need. You don't need to understand the details about database configuration. What do you need? Specify what exactly you want, which is just table, right? A few attributes here, quite simple. I think I can do that. All right, that's step one we just mentioned, fully functional application stack. Step two. What if someone makes a change? Do the click ops. In this case, you have database table running, right? And you have lots of tags. Very important you have tags because you can do lots of things based on tagging. But someone in this demo deleted manually, which is definitely anti-pattern, but things happen. And then the tag is gone, right? Don't worry. Like I mentioned, this infrastructure controller not only just do provisioning, it ongoing monitor your current environment with the desired state and reconcile. Let's look at the log files of cross-plane. It's up to date. This is the last time finished the sync. Give some time, it will capture the deviation. Here we go. We got something going on here. And apply sync updated, right? So which means it triggered provisioning update of the resources. And then we go back to our database table, do a refresh. Hey, we have it back, right? This is a way you can ensure environment up to state. Step three, what if someone, like a developer, you misconfigure your code and you didn't put tag in, right? But we want to automate this policy enforcement. So let me introduce your concept called OPA, which is a policy engine. Here, I'm going to walk you through. We deploy that OPA gatekeeper, which is basically like a webhook to your Kubernetes cluster, do the mutation and also the validation. And here, we need to deploy two components, constraint template and constraint. So basically, this is just a policy as code, right? Specify what exactly allowed in my environment, and I deploy that. And the policy engine OPA will look after and execute this policy on your behalf. But it's running in the backend. You don't need to worry about it. Always there, and to validate your upcoming traffic and upcoming request. Now it's there. Let's do a testing. Basically, I have a table I want to create. Again, I also use GitOps to do this demo. I just go back to UI. I create a new applications. And this application still use the same approach. And put the URL of my GitHub repo and address for my code. And then I put my default cluster as a destination. The same thing, I will do the sync up. Let's see what happened. Oh, look at that. Something wrong, huh? So basically, this means your cluster didn't allow me to provision the resource. Right? It's because that's what we expected. It doesn't have a tag. Missing, something missing. The developer didn't put that in. How can we fix that? We need to go back our code. And then we just commit, make some changes, right? So as you can see, we need to comment, remove the comment tag, and add the text back in. And then, because I changed the local file, I need to commit to the remote. So that's my source of truth. I can sync to my environment, to the latest code. Yeah, it's working, right? So that's what we expected. All right, that's a demo about 3 steps. Let's move on to the best practices, what we have been through, right? We basically talk about GitOps, Kubernetes, and also with source of truth in the YAML file. And backend, we use infrastructure controller to handle everything, and more guardrails. Build a platform, we need to work with your customers. Who are they? Developers. And then start with meaningful use case. Don't boil the ocean. Most importantly, there's no one size for all. Always have different options. Continue adding capabilities. Continue learning with these resources. Get your hands dirty, and also look at reference architectures here. And in the end, as a developer with all the best practices, I have more confidence. Looks good to me, right? Means always have consistent outcome with expected outcome. Thank you, and please read our session. Thank you so much.